Before there was fire, mankind never stepped out into the dark. Before there was the wheel, mankind was confined to the extent of their feet. Before there were tools, mankind molded and made with hand. Before there was the brick, man lived under the shelter of nature, under trees and within the dark depths of caves. Once there was brick, man built a house for himself and then a home. Our lives are intricately woven within the threads of technology into the tapestry of human evolution, where each surge of advancement emerges as a reflection of the technology of its era. These shifting paradigms in technology intricately mold the essence of existence, subtly transforming the very spaces we occupy and inhabit. What we experience now is a product of the technology of the past, in the same way that the technology of now shapes the future. Step by step, brick by brick, humanity and its various habitats have been slowly forging ahead. There is no other period in the history of time which emphasizes the breadth and power of innovation more than the Industrial Revolution. Spanning from the late 18th to the early 19th century, this period saw the birth of the groundbreaking innovations like ocean liners, grain silos, aeroplanes, and automobiles, technical beauties which, according to Le Corbusier, are the commencing of a new age. A great epoch has begun. There exists a new spirit. There exists a massive work conceived in the new spirit. It is to be met with a particularly industrial production. Architecture is stifled in custom. Our own epoch is determining day by day its own style. Our eyes, unhappily, are unable yet to discern it. It is right before our eyes. Eyes that do not see. The great age of the machine has arrived, and with it, architecture has witnessed the appearance of a new element, the mass production spirit. The engineer, inspired by the equipment of our time, has substituted for the stone and brick of yesterday, glass and steel.
Stark, uncompromising lines of brutalist architecture, one discovers a haunting romance that intertwines with the very fabric of industrial innovation. Steel and concrete, the twin titans of modern construction, enabled a daring reimagining of space, giving rise to monumental structures that rise like stone sentinels against the horizon. These materials, born of industry's relentless pursuit of progress, shape a world where raw, unadorned forms speak of a dystopian vision. A vision where humanity's ambition for permanence and grandeur clashes with the harshness of its own creation. In these concrete giants and steel skeletons, the fusion of technology, might, and existential reflection forms a melancholic yet mesmerizing ode to a foreboding future.
If I look at the way Corbusier paired with concrete, there's a kind of very pragmatic technological considerations. Like, for example, he treats concrete like stone, glass. So they were exploring a certain quality, otherwise that neutral wouldn't have emerged. That qualitative exploration has somehow diminished because of the pragmatics of exploration.
The dawn of new technological advancement opened a gateway to uncharted architectural exploration, liberating designs from rigid confines of brutalism. With each innovation, architects became dream weavers, their imagination soaring to explore forms and geometries previously confined to the realm of fantasy.
New technologies are helping evolve new kind of hybrids of buildings which we had never thought of before, and it has opened up immense opportunities for our younger generation and a chance to explore new kind of buildings within new kind of context, and to the extent of even imagining cities which are partly underground. In the Guggenheim Museum competition, what we did was, because the density of Manhattan is so strong of the skyscrapers, we felt we didn't want to do one more skyscraper within that context. We decided to take our building underground. The building goes almost 30 to 35 stories beneath the surface, and we decided to have an open plaza on the ground, very much needed in such a dense urban context. And of course, in order to imagine such a construct, we had to also think about how the construction would happen. So that is where the technology part would come in, wherein we did talk with a couple of consultants, and they mentioned that the same technology which was used for mining purposes would be the same kind of technology which could be applied over here in order to go down deep into the earth and create a whole void.
To a great extent, there are softwares, there are technologies, there are amazing bending machines available in the world where every element which you are drawing can be bent in 360 degrees. Learning about the form of pure force, understanding this form in 3 dimensions is very helpful in 3D modeling or 3D printing. We are going into a zone of more of technology, more of experiential understanding. Through technology, we are able to experience the force transfer. You can see the stress diagram. You can know how the puncture can affect the whole structure. It's fantastic.
The possibilities are fantastic. On one hand, I have felt that it threatens the discipline that is ours. On the other hand, I feel like it has some incredible freedoms that we can explore. I don't think that the value or the ethic of use lies with the technology. It lies with us. So even with AI, I don't think that ethic lies with the machine, the tool itself.
Current innovation and technologies now, we do mention aerial photogrammetry, GIS mapping, or even drone mapping as such. I would say none of them are inventions. I would rather say these are evolutions. These are progress of our understanding and applications from basic sciences.
I would say the technology would come in some sense at a very early point of the project by imagining what would be a blade wall, what would be a shear wall, how can I suspend a volume into a space, how can I make the ground freer, how can I work on which is the lighter volume and which is the heavier mass, and how do I play around with it. So this kind of materiality and this sense of structure also starts getting evolved during this process, which we of course take it into the design development stage at a later point of time. In the case of the library within the park, the library was within the setting of Central Park. We decided that we didn't want to put our building straight away on the ground because it would involve cutting and chopping off a whole lot of trees. We decided to lift the building up above the canopy of the trees, and for that we innovated the construction and the structure whereby there would be several pods which would be made and the building would hover on top of it like an entire bridge, and the building can grow in different directions as and when the future needs could be. The context becomes the driver. The context forces us to think about a new kind of a structure, and this new kind of a structure opens up immense opportunities for us.
I actually think that it will be possible for anybody to build quite a sophisticated or design quite a sophisticated house for themselves. And if AI allows you to do that, engage with various platforms and make that possible, I don't think that that's necessarily a bad thing for us cities.
I look at an element which is unstable, and then I use this unstable element to be combined in a particular way to make it stable. Look at a bundle of paper tied by a thin steel wire to stabilize this bundle of paper. So you are inducing density into a very low density material. The ability of marrying density calls for a technology. Why I can't make buildings with low density material, an ability to breathe and still confined with tension cables into the ground?
There seems to be over time a universal idea of architecture. There are no acceptable methodologies, certainly economics, which decides how you should place concrete, what are the relationships between plan area, configuration, surface area that reduces or optimizes costs. no longer can have the freedom that they had at that point when they are new, in which there's a spirit of exploration, finding out about that. If you were to look at it culturally, we have understood concrete now, or we understood steel and glass now. We know that the developer uses a glass facade, not because it's cheaper in terms of material cost, but it's cheaper in terms of time. It's just faster to put up. Therefore, it's not just that the epoch, the technological race, and it seems to be transforming things very fast. And when you actually walk around and look at things and look at the physicality of our world, I mean, largely remaining the same. One begins to wonder on what does this technology really have impact. There have been two kind of ways of looking at that statement. The house is a machine to live in. We tend to concentrate and focus on the machine part of it, the technological part of it, material, structure, the envelope, the organization, new techniques of assembly. In some sense, if you are going to go backwards and look at a more continuous history of the house, then the emphasis has been on living in and not necessarily the machine. And technology is always assumed or accepted to be part of the context in which one is built. And even in the living part of it, how you live itself has its own technologies which are not necessarily based or connected directly with the technologies of living. I might ask, how has the refrigerator changed my way of living as a technology, which then has impacted the house? I'm not necessarily looking at it as something that has directly impacted the form of the house, but it has certainly changed the way that I organize and think the house. We tend to think about the history of the house as the technologies of the envelope, but we get much more interesting and complex histories if we start looking at all the technologies that are also associated with the living part of it. When I think about architectural histories as only looking at the envelope, isolated from all the other technologies that shape life, as in Chaueasia's question of a machine to live in, then we get very warped understandings of both technology and life and how the two kind of come together. And unfortunately, I think that is what has happened. We misunderstood the role of technology in the making of architecture in relation to architecture and our lives, which unfolds in. And therefore we separate it. And therefore we think also that this question of only looking at technologies vis-a-vis building is sufficient, which I think we might want to kind of open up a little. In our cities and our context, some of the houses always crack open. The houses are a little bit unfinished, and you can see life inside. And therefore, the relationship between the technology of the envelope and the technologies of life somehow have always been visible and evident to us. That's why looking at certain types of settlements has been a preoccupation with architects in contexts like ours.
Technologies of the global north differ from technologies of the global south when put into the context with site, climate, society, etc. Hence, there is a difference in the kind of innovations as well. A vast part of the global south still looks at labor-intensive technologies of the hand.
In India, until and unless you don't experience something, you can't work with it. If there is a material, until and unless I don't handle it, I don't come to know its full potential. In an experiential form of learning, you are constantly working with it and innovating. So it's not just your mind that is working, but it's your mind, hand and heart. The three come together. It's when you are making a pot with clay, you are able to understand its full potential of how big it can become or how much I can make it go out by just understanding the properties of the mud, not through calculation, but through my hands. So a craftsperson is able to know the potential of a material through working with it with their hands. I'm not rejecting the importance of calculation. I'm saying the combination of being able to work with the material and being able to do some calculations creates innumerable properties and possibilities.
Hand should be remembered through the art of making. The birth of the brick happened between two hands, between two eyes, to the width of your head, which is 230. Why people have not made a 1 meter brick? The hand decided that I will make the limitation of my scale. Today the birth of the brick is all over the place. One seed can create a building of 1 million square foot.
In many cultural contexts around the world, I'm not sure that there is a clamoring for advanced technologies. And one might argue because there's no market reach, etc. Yeah, but we also know the politics of that and the creation of desires. There are a large number of people and peoples and cultures that are reasonably stable with technologies that they're using, which are not what we would describe as advanced.
Normally, one understands tradition as something that is fixed in time, but that's not the way it is. The word parampara itself, param means now, and pare is to move away from the now. Tradition has also been constantly changing. The problem in India was that we never recognized these building systems as being valid. They were considered, so to speak, kacha. A lot of the people who lived in these technologies or these ways of construction were in the rural areas. Most of the engineers and architects who got trained never understood these materials of how mud or bamboo or stone or lime or any of these materials can be built with. The people of these traditions were not considered advanced. In spite of that, they continued to follow these traditions. And that was because it was very strongly imbibed within their cultural ways of thinking.
You have these portals. Portals is made of the thighs. So the thigh is bigger and thinner. So this is the thigh. And today we are duplicating hand into a robot to do this one. But nobody knows what is the potential of this hand.
Changing context means I'm not in the same context as Mr. Foster, and therefore my understanding of technology is very different from his. Certainly here, I think that only advanced technologies is a privilege, but technology abounds. All around, people are engaging with various types of technology, and it's only when you add that advanced that suddenly what is somehow newer or sophisticated gets value, and we get hierarchies of technology. But we are all engaging with technologies of various types.
Modern cities are being developed with the help of technological advancements like cement, steel, glass, so that's how we are able to go for skyscrapers. But even with earth construction, it can be possible. We have examples in Yemen where people have built 7-storied buildings to 10-storied buildings with just earth as the material.
So many cultures are living this way of building, and yet our cities are building something else altogether. And it is these artisans who come from the rural areas who also build according to what urban areas require, which is the classical form of, so to speak, permanent buildings. It never remains permanent. Concrete actually has a lower lifespan than mud does. If you go into tribal areas, you will find mud buildings which are 150 years old and still standing. And in cities, for example in Mumbai, concrete building will not last more than 70 years. It's a misnomer that mud is impermanent.
You might not find multi-story building without a concrete slab. So if you ask me, the method which we use with vaulted structures and dome structures to build your intermediate floors and to build multi-storied apartments, all in a load-bearing structure, is a cutting-edge technology to us.
When we went to Bam in Iran, Bam is a beautiful town which is in the middle of the desert where the entire city was made completely in mud. And they make beautiful domes, vaults, all completely in pure mud. But unfortunately, because new materials were being brought in by Iran, iron girders, iron sheets, they were just adding that to the mud wall, which made the original structures weak instead of actually making them strong with iron. And in an earthquake, the traditional buildings which were only made in mud did not break. But all the buildings that were a mishmash of tradition and new materials, they broke down and fell down. If you are bringing in new materials, it has to be very carefully developed and added in such a way that you are actually strengthening the traditions and not weakening them.
Traditional technology had very appropriate application. Like lime was a very good insulator as well, breathable material, and it is a very apt material for the masonry. But what has happened ki we have got a very new material, cement, which was very rigid and very good strength for the concrete but not for the masonry. But easier way of using cement was much appealing to the mass that has affected the lime. We should appreciate the technical aspect of that traditional technology where we can use it positively. Combination of pozzolana and lime, that is surkhi and lime, was very good application. That can be adapted for the lean concrete concept. One can make bricks and blocks out of that, and that can be a recycled material. So resource efficiency is there, performance is there.
If you take the older techniques like let's say Adobe, Cobb, and and rammed earth. Our aim is to put it into a context where even a normal person can relate to it, or a normal mason can do it easily. CSEB as itself is an example because it is a derivative of rammed earth and Adobe together. So rammed earth we do a whole wall compressing it, but CSEB we are just making a brick compressing it.
And invariably, even the technological innovations that take place are not done by us alone. We work with master artisans from their traditions. So I'll give you an example. If there are 100 potters, everybody will make the matka, but one out of them will try and innovate the matka a little bit. So we try and identify who are these innovators, and then with them we do workshops. And in those workshops, new ideas come up. We give them something from science, they give us something from tradition. And a combination of two ways of thinking always creates innovation.
Cement has been a bit old, but the innovation in cement also, polymer mortar, etc., is very rapidly changing the basic construction technique. So what we have emphasized is on combining traditional with the modern application, as lime was requiring very elaborate preparation at the site. So we tried to eliminate that and prepared it in a dry form which can be used on site. That type of adaptation would make sense.
In Japan, different types of cross-laminated bamboo is available. In cross-laminated bamboo, buildings are coming. That is also material. Not only this aluminum composite panels, and they made 25 floor buildings there with that cross-laminated bamboo. They completely avoided steel. But the time being, the cost is very. Similarly, if it is a composite building, not only bamboo, not only mud, we can make a composite building. We can also make multi-storied building with maximum use of bamboo. We can replace entire steel and concrete, not only the steel reinforcement with bamboo, RCC, and their slab can be converted into bamboo slabs. Technology is coming up. Our office building, we are making a framed structure with bamboo slabs, and the walls also with bamboo. 80% material is renewable and recycled, and 20% material only with steel and concrete.
We use CSEB for construction of walls, main walls, and then even the roof structures, vaulted roofs and dome roofs. And we use these roofs to also make intermediate floors, so we make apartment buildings. CSEB is like a one-stop solution for us in Earth Institute. We have a lot of scope with that material. CSEB is more of a modular construction. We have the same modular blocks which we keep repeating again and again for the whole wall. It's more like how you play a Lego block.
And if it is a high-rise building, we are using waterline top inside. Because of the wind and rain, the chances of splashing it off, washing it off, this entire mud. Instead, if you make a bamboo skin outside, the building which you have seen in Lorry Baker Center, that is actually a bamboo skin outside, which will prevent entire rains outside. That will not come to the mud. That is all innovations. In that waterline top, we started using kaya fiber in it, which make that mud more strong. When we use borax and boric acid, it's the life of bamboo is increasing.
Recently, we use poured earth concrete. This is similar to a cement concrete. It has cement aggregates, fine aggregates, coarse aggregates, and we also add soil along with it. So there are 4 elements in poured earth concrete. But the workability is more like a cement concrete itself, like how you mix a concrete in a mixer or hand mixing, and then you use a vibrator to distribute it. It has been a good innovation in terms of increasing the work speed. So you can create a wall, and also you can make load-bearing foundations with poured earth concrete. Helps us reduce the workability time on the site, and compared to the other techniques like rammed earth, cob or Adobe, because they are a little slower in terms of construction speed and they need their own time to produce and to execute on site. Until now we use poured earth concrete only for making solid walls and solid foundations, but we have not tried having reinforcements in these bars, because basically earth as a building material does not go along with steel reinforcements because steel corrodes in contact with earth. We were trying to make poured earth beams to see how that works with respect to reinforced concrete beam.
Bamboo is one of the best material for making prefabricated. We can make bamboo panels and transport. In factory we can make that, because whatever we are getting the spaces now, it is a wall. We can just transport the wall there and just fix it at the side. We can construct faster. When we are completed our design, that time itself we can start the roofing and walling.
The machine developed abroad or the technology developed on the corporate level would be very different than what we require at small scale industry. We need to adapt the machine, or nowadays they have adapted hydraulic presses. Otherwise it was in earlier days, 90s and period, they were using hand press only, or no machine mixing was done. Mixing can be mechanized, and mud block production also can be on the press, which will give you very good productivity, and that will reduce the labor component. For my concern, cutting edge technology would be the testing of the material, because when we want to use waste or we want to use some other material, we need to have the characteristic of that. Testing will help you to understand the material and incorporate that into manufacturing.
We do not use any kind of formwork or shuttering to make walls and domes. That is also a technological level because we have the skilled labor to do it. And we also use extensively ferrous cement technique to build structures. You get these thin profiles of cement based elements where you can make flexible doors, gutters where cast the concrete beam inside the gutters itself. We don't need a shuttering on the outside. The next one would be the interlocking blocks which are developed from the RM press. So it reduces a lot of time. It is almost equivalent. It's even less than your conventional building sometimes.
We were in Spiti surveying the mud houses, and there people started using concrete building as a house making method. With the concrete, the condensed cold was coming much more inside the house, and because of that, condensation was the another issue, not only the heating. And that mud being such a thick material, it was quite insulating. So they were adapting or the combining both the things. Wherever possible, they were using mud, and for the roof, they were using concrete or concrete plus layer of mud as an insulation.
Even if they are doing normal residential scale buildings with 3D printing, it will be using a lot more energy. So that is kind of adding up to the overall embodied energy of the building. That is something which we keep in mind because we want to keep our embodied energy as low as possible as well. So when you talk about that, then going to your traditional technique is the best solution to go to, even though the process takes slower time. We need to understand slow things are always better on a longer run, I'm saying.
In a developing country like India, there's a huge gap between advanced knowledge systems and the resources available to implement it. The crux of Indian innovation, however, lies in that gap.
What was beautiful about this country is that everybody thinks differently. Everybody's idea of an ideal is different from the other. In the cities, everybody has got into a certain rut. It is largely borrowed from the West. In Indian cultures, it isn't like technology wasn't changing. It continues to change, and whenever we go and start working with these cultures, we always give them a choice. We give them something which is completely traditional. We give them something which is an upgraded version of their traditions. And we also give them a cement and concrete house. And we ask them to choose. We have made more than 2.5 lakh homes in rural areas, and we find that invariably people choose the second option. Many choose the first option because that is something that they are used to, but almost 60 to 70% will choose the second option. And the reason is that they are solving some of their problems. When we introduced the idea of ram dirt in Kutch, a lot of people like the idea, especially women like the idea because they don't need to do lipan every year. So it was solving a problem for them, and it was still using mud, which was something that they were familiar with. They knew how to build in that. Even in bamboo, when we were working in Bihaag after the Kosi floods, we developed the bamboo joineries in such a way that they were tied, that they were more resilient, that they were longer lasting, the bamboo was treated, and as a result, many people like the idea of using bamboo for their homes. Over there you get floods, you get high velocity winds, you have earthquakes, and this bamboo house was able to withstand all these three disasters. There is always a process of addition and not rejection of something to adopt something completely new.
When we were not having such a technology, we should find some way to get the technology. Once you get the technology, you are open to that and you are equipped with more skill to develop further. We have developed our own liquid stages and liquid engines and cryogenics. We should not shy away from interacting with our community and get the thing. But there will be a situation they will not give you. You have only option to develop yourself.
The necessity of technology is something which you need to develop. Every technology is come out for a particular requirement, and then you can apply it. Looking at technology and then starting building may not be the right way. You create technology to the need of your requirement.
What all technology we are currently using is, for example, computer. In some 30 years back, this type of computing facilities were not there. Now we are having a very good computing facility. That is advancement of the technology, So that computing facility is helping us or has helped us to do more indigenization. Indigenization means developing the technology within our country for the benefit of the country by our own people. All these advancement has helped us to do in a faster way our indigenization.
I do not believe one technology can solve all the problems of conservation practice or requirements. I certainly look forward to an inclusive methodology where the traditional methods are given enough that can be made or applied towards the technological understanding and their potentials that can be taken forward to the future. It is very important for us to bring in technology as a normalized aspect where these things are accessible and affordable. In the Indian context, the questions we asked are, is it accessible? Is it affordable? Is it available?
My iPhone fell in water and I went to Apple. They were going to charge me a patent. Might as well buy a new phone. Second line of defense was the roadside mobile shop. Repaired my phone for about a fifth of what Apple had quoted. It's a kind of hybrid phone because it's made up of parts which are not Apple. And somehow he sourced them and they put it together. It took 2 weeks. No use of that phone. but it's happening all the time. It's continuous. There's no start. It's already on and it's ongoing. The start is only important if you want authorship. If I am part of the Jugaad universe, then I am in that scene. If you want to know when to start, that means you are expecting to get some kind of credit for it so that you can express the individuality of your innovation. And that's not Jugaad. Jugaad is anonymous. The minute you give it authorship, you lose it. Because it is handed down, handed sideways, handed backwards. It's an attitude of material sharing.
In his essay titled The Indian Way of Thinking, A.K. Ramanujam highlights how Indian thought is characterized by its complexity and nuanced understanding of reality. Unlike linear or dichotomous approaches, Indian thinking often embraces paradoxes, multiple perspectives, and a holistic view of knowledge. It is said that necessity is the mother of invention. This notion, driven by the aspiration to achieve maximum efficiency with minimum resources, is what drives the Indian concept of Jugaad.
Two old doors stuck together. You can shut it from this side or you can open it from that side. Just any old thing. This is some old key. Put it in that hole. Now, will you open it? He can't get in, so an expensive lock. If you must have a grill, this one is a clutch plate out of a car, and then this is a bicycle wheel. I just use envelopes, old envelopes, open them up, Christmas cards, put them all together, and I've got a writing pad and can keep it in my pocket.
You ask the question of each item, however small, is it necessary? If it's not necessary, don't do it. If it's money that you're trying to save.
Every product development, we will adopt a design which is bringing down the cost, because within the budgetary requirement we have to complete the project, otherwise it will get prolonged and cost will further enhance. So given the project cost, minimum cost designs are made, conceptual stage itself, and realized that is known to all the engineers in SR. One of the spec will be this point, that is easily manufacturable, realizable design.
You'll see how architects kind of privilege authorship, that some by using mud, it means something to my project, and so it's also symbolic. But in Jugaad, there's the symbolic completely gets suppressed to a kind of practical, I don't have a better word, continuity. And the whole thing about this CE of Jugaad is that it is done with things which are close at and passed on from hand to hand. And in that there is an absolutely fundamental physical continuity. It is about simply looking at the potential of something and transforming it and using it to fill the gap. So ISRO is able to do what other spaces used to do at a third or whatever, 10th of the cost. Because we have a certain attitude to that technology, which is, I don't know, it's continuous, it's practical, it uses what is close at hand. It looks at relationships rather than looking at entities.
We redefined our ways of looking at technology by the introduction of the Jugaad. Dense urban spaces like the Koliwada settlements or the fishing village Dharavi, one of Asia's largest slums, has been innovative architectural solutions inspired by Jugaad. Architects and urban planners have integrated recycled materials, sustainable building techniques, and community-driven design principles to improve living conditions while preserving the social fabric of that area.
Without constraints, your creativity is lost. It's only when you have constraints that you are innovative. The government of Bihar said that we have only about 55,000 rupees for a building. And so that provided a certain constraint on us, that in 55,000 can you actually design a full house? And that allowed for so much of creativity to happen. When we sat down with the Dabia Mistris, who are bamboo workers of that region, they said that we make bamboo houses for 30,000 rupees. So 55,000 is a lot of money. And so we started innovating and we started creating a plinth which was in bricks, because we had the luxury of doing something more than 30,000. And I'll give you another example. In Nepal, when we were working with Tibetan nuns, they had a constraint that we will not cut trees because Buddhism doesn't allow, because they feel that trees are also sentinel beings, and they were in a very remote area. So whatever could be carried on the head or on the body was the only materials that could be brought in. To make earthquake safe stone and mud housing, we brought wire mesh, and that wire mesh was put in different layers along the walls, and that was tested for earthquake safety, and it worked very well. So whenever there is a constraint, it allows you for innovation.
Earth Institute as a unit, we try to adapt this from the base of the material itself. Any traditional method which you take, even though how much ever you want to develop that technology, you are going to have site-specific limitations or conditions which you have to adjust to. CACB requires a specific kind of soil. We need more of a sandy soil because sand is the element which takes more compression in a block. Here in Auroville, we have a silty sand soil, so the percentage of silt is a little bit more. What we try to do is we adjust it with adding more sand, river sand or M sand in recent cases. Being a site-specific method or technology, it also kind of reduces the cost, or being the jugaad approach, like being the maximum efficiency and minimum cost as much as possible. We reduce a lot of transport, we reduce a lot of unwanted materials in the site.
So there's a Gracia Bhil community here in North Gujarat where they take out a laterite soil from under the ground and make rammed earth walls. The wall can go up to 25 feet and it is all exposed to the rain and the sun and the weather. And yet it was not eroding. So we took a part of the soil and we sent it to the laboratory and we found out that it has a laterite soil which has iron hydroxide. And when it is exposed to the atmosphere, the oxides are released. And ferrous oxides are extremely good binders like cement. And so they were holding all the particles together. Over the years, as it was coming into contact with more and more oxygen, it was becoming stronger and stronger. Similarly, in tribal housing where they use cob, they use a lot of clay. And especially the last layer is completely done in clay. And the reason for that is that the moment it rains, moisture comes onto the clay particles expand. Doesn't allow the rest of the rain to go into the wall. So it creates a protective layer to protect the mud wall. So it brought in a modern material, a new technology was developed, but within the cultural and technological framework of the way they used to build.
We have been trying to incorporate movable houses, disaster-resistant houses and cost-effective houses in a lot of places. We have some examples in Auroville, we have some examples in Tamil Nadu. The disaster-resistant methods which were used after the Bhuj earthquake, that it's also part of the jugaad approach because they wanted to build the house in a very short time and as cost-effective as possible because these people were affected. We used prefabricated way of construction. The roof elements, the walls, the blocks which we use, the foundation, were all precasted in a way that it could be put together in a shorter time. It uses a specific kind of CACB block which is called as the interlocking blocks. So this uses very thin mortar, like 5mm mortar. It looks exactly like a Lego block. It has positive and negative points where you can just keep interlocking it as you go up. Because of that specific block is one of the reasons we were able to attain that speed. We were able to build it within 72 hours or 3 days or 4 days.
We have adapted one concrete paver machine for making soil block. That was a totally automatic press designed for paver manufacturing, and we took it for soil block making. So requiring that minute adjustment of mold filling height से लेके उसका vibrating and pressure changing, we did a lot.
If there was only a certain amount of stone that could be harvested from your environment, you only harvested that much. If you needed bamboos, like in Bihaag, every village has a bamboo grove from where they take their bamboos for making their homes. So there was a constant understanding of what nature can give. And you only took that part. You didn't try to do more than that. And as I said, we have done a lot of collaborations with rural communities where we have innovated together and built within their systems. We have tried to keep external materials to the minimum because we are trying to encourage a low carbon building system because 37% of the greenhouse gases that are being emitted today is because of construction, urban construction. So if limestone was available in a certain area, you use lime in that area.
Bamboo beams are there. We have to adopt our Kerala bamboo. We are talking about locally available material and northeast bamboo is bringing it here and construct. We are using Kerala bamboo, Trivandrum bamboo. And that bamboo is slightly, the straight bamboos are very rare. Maximum will get 10%. Rest of the bamboo is all. Then according to that shape of the bamboo, we have to adopt or change our technology in that. That 10% straight bamboo, we are using it for bamboo beams. And every 1.5 meter we place bamboo beam and the 1.5 meter bamboo cost. We put mud deposit.
CACB, even though we have developed this technology, we don't force this technology throughout India. Based on the soil type and based on the context, like the region type, we adapt the construction methods. If you find clay soils, we can always go for adobe or cob as a technique. If you have more of a gravelly soil, then we can go for poured earth or rammed earth. If your soil is not suitable enough and you have a dense forest like a rainforest area, like in Assam and Arunachal Pradesh, we don't force you to make CACB. We say, check if you have a better construction material, use that. We use earth for the places where we have to use it.
Country type bricks. So normally now it is not been manufactured. So what we have done is we have taken their country size. Normally it was 300 by 150. we took the thickness of 50 mm, but the size we converted into 350 by 230, which is in the module of regular brick, 1.5 brick by brick. So that type of changes have helped them to design a building very easily or to adapt that country brick for the modern construction.
With CACB, since it is compressed with the machine and also it has a good finish when compared to, let's say, Adobe blocks, we don't really require to plaster all around the surface of the facade. We see the climatic conditions of that region. We find out which facade faces the heaviest rain. Based on that, only those facades we plaster. So this kind of reduces that extra layer coating. So we just use it where it is actually required. The rest of this place can be exposed. Even in our campus and most of the projects which we are using, we use plasters where it's actually required. So interiors will not have any plasters, but most of the cases, exteriors we use as less as possible.
And earlier we were using a finish called white cement finish. We call it marble finish. It was a traditional method. Earlier it was done with lime. Now that quality of lime went down. Now we are adding into white cement also. That finish is also very good. And there is no joints. There is no water leak.
The kind of contextual variations in terms of regions, culture, geography, climate, we are a subcontinent, and every time there is a different challenge that is thrown at me. Now, how do I jugaadify this? It is the understanding that comes from the context and the ability to adapt immediately to be able to overcome that challenge. But there is another thing that we need to understand in digital technology is the understanding of imaging. With the understanding of technology, with the understanding of science of light, with the understanding of surface, the jugaad comes out.
We have to meet high quality space products, or rather launch vehicles or satellites or whatever services what we are offering of. World class space quality, design wise, material selection wise, testing wise. To meet the requirement, what is the best solution we should have? In the design phase, we are having different choices. We will not blindly follow one design. We will make different designs and see the merit of each one from our role point of view, then requirement, specification meeting requirement point of view, from realization point of view. Definitely cost will be another aspect. All these aspects will be considered for each design. Everywhere the same approach only will follow. Reducing the cost, easy, simple design, then easy realizability, then sufficient testing. All this will be bringing down the cost, development cost as well as operational cost to the minimum. In the development phase, if we are missing, it will reflect in the operational phase and it will enhance the cost considerably. Failure will increase the cost. So bring down that minimum, testing, realization, everything will be done to the required level and we are flying it. That is the approach we are following in launch vehicle area.
Use only whatever is necessary. Then you have to see or you have to find a solution with the most economic way, with good materials, best materials. That's why it is called cost effectiveness. Here is the difference between low cost and cost effective. Very high quality material with the minimum price is cost effectiveness. Maybe price as well as the quality is less is low cost. Our buildings are cost effective, cost and energy effective.
I'm not a secret drinker, but we collect all these coloured bottles and make them into panels that we can put as decoration in the wall. You get lovely colours in a dark wall.
For me, it was always a guiding principle that we should maximize the recycled content or the resource efficiency of the material. So for that, we have taken pozzolana and lime reaction. If you look for the pozzolana, then you will look for the other areas other than the fly ash. Fly ash is very popular pozzolana, but at the same time, surki is there. Tile waste is also a pozzolana. As and when we say it is a recycled material, people will see with the doubt because the another material available is a virgin and proven for so many years. So we kept some higher standard than the local materials, which gives minimum strength, water absorption in a controlled manner. So that will perform. What waste we are using is a inert waste. It's not hazardous waste. So one can use the material wherever one wants to.
As you know, the launch vehicle, once it is doing its function, stage by stage it will be separated and discarded. It will fall in the sea in the safe zone. Recycling is as such not possible, but the reusability is there. That ISRO is developing a new reusable launch vehicle where all reusable technologies will be demonstrated. 3 flights are RLV, reusable launch vehicle. Lex 01, 02, 03, and it's in the process of further fine-tuning.
At present, most of our buildings, 99% of our buildings, we are using recycled windows and doors. Now the price of windows and doors are, because it's all very poor people also who are using it. Whenever a building is demolished, that information will come to us. And I will not say 100%, but 99% of our building we are using recycled building materials. That's a type of approach. That is what the Bihaag says.
Another thing, people are not using waste because we don't have a cost to dispose of the waste. Whenever we control the disposal of waste, then the value of that material or incorporating into the another cycle would make sense. Nowadays what happens that still our sand and aggregates are cheaper than waste. Whenever you say that I want to use this waste, the waste will have value because one has to handle. Whoever is disposing, he will see himself that I should get something. And the another is transportation and handling of the waste. And that is costlier than the virgin material like sand and aggregates.
Even these traditional techniques can be put into cost-effective situation. If you look at the current context, it will not be, because the laborers which are executing these kind of buildings have become skilled laborers because they have all forgotten how these techniques are to be done, and that is why the rates in terms of labor is increasing. So if you take the context of any earth construction technique, the material is mainly earth, and earth is found everywhere under your feet, and this reduces the material cost. But again, being a skilled labor, that's where the cost increases. He specialized in it. For earth to become more cost effective, we have ways. We have these interlocking blocks and disaster resistant houses which are cheaper, but still it's going to take a longer time for the earth as a building material to get cheaper.
When a technology, though it looks easy, though the tagline of open sources and free softwares are available, but in a country the affordability and the availability and the accessibility is always in a question.
I think rural areas had a sophistication of being able to live within their means, which urban societies have forgotten how to do. So whenever we have worked with communities, we have innovated within their vocabulary. Say about 20 years ago, green architecture was not possible. There were just a few buildings that were coming up, but it was primarily not possible because there weren't any artisans who can make buildings in all these traditional materials. And clients and architects, even though they were interested in doing green architecture, were apprehensive because one, technologies had not developed sufficiently for urban areas and artisans were not available. And there were a few practices who used to hold their artisans very closely. They would not share their artisans with anybody else. So we decided to democratize the space because we realized that there was a huge demand, the supply was a problem. So we created platforms for building artisans and made them available to architects and clients. Over that period, we also developed a new vocabulary of building with mud, bamboo, stone, lime, etc. in urban areas. This is what allowed for a huge number of people to be able to get the confidence that you can build green buildings.
I think innovation is happening wherever there are needs felt. Gaps are being filled all the time.
When it comes to the accessibility of digital documentation techniques, I'm sure we are in a far better place than we were 10 years before or 20 years before. But have we reached our destination yet? Has this journey given us enough in comparison with the kind of cultural assets that we have in our country? I would clearly say no.
So even in India, you have two ways of thinking. One is what, say, the tribal communities. They believe in the impermanence of things. They believe that everything is constantly changing. Whereas the classical form of thinking, where there's a teacher and taught, in the folk way of thinking, you learn by doing. They don't believe that a house is permanent. They believe that the house must decay, it must go back into the soil, and for you to be able to build again. In all bamboo-based construction, they'll always never nail or bolt something together. They will always tie it together because the bamboo will need to be changed in the future. Out of 8 bamboos, 1 bamboo might rot. So there should be a provision to be able to remove it and put a new one. This way of thinking is accepting change, and therefore you allow yourself the possibilities of doing things impermanently.
The question is of appropriateness. You don't use a titanium knife for butter. It would be ridiculous to use that technology that goes into cutting a ceramic shell of a space shuttle for you, and choosing the appropriate technology for the appropriate action is something that most cultures are very good at discerning. I'm saying that high-tech processes for a metro, absolutely necessary. The scale of the metro, necessary for certain scales of cities. But I'm not saying that for a school building, I'm not saying that you need high-tech. I don't know what that means exactly, but I'm not sure that there should be an emphasis on advanced technologies in school, because that might change certain kind of modalities of teaching, but then that takes us away from the question of what one is teaching. And we often say in architecture that we are pretty much building the same way we built about 1,000 years ago. And I think that's something that one might keep in mind when one is kind of talking about the advancement of technologies, whether it's a symbolic desire creating technology or something that has genuine implications within that context.
Jugaad comes when the heart, hand and mind work together. And I'm bringing the heart as a very important component, because without motivation you can't achieve anything. So that's why handcrafted buildings are a way of life, it's a way of being as against linear process of understanding things before you build. So you can make a pot either with your own hands or you can make a mold and make the same pot. What is more enjoyable? So I don't think craftsmanship will ever become obsolete because the process of doing something with your own entire body and being is extremely enjoyable. It's the same with buildings. I feel handcrafted buildings have a very rich future, and all these 3D printing systems of trying to do fast construction or easy construction or more precise construction will never take away from actually doing things with your own hands.
Architecture, in my understanding, is an everyday technology. The technologies for it are everyday, are not necessarily advanced. And therefore, it's a question of finding, connecting, making relationships that are tied with technology. The technological part of it, the material part of it, it's not trying to be exaggerated beyond what it is.
We are only giving, preference to the eye just because we see. We talk to people what we see. We don't have any depth to go beyond what we see. You need to embrace technology to a great extent that it is a necessity than a fashion. For that you have to upgrade yourself to think in 3 dimensions, to visualize in 3 dimensions, and an ability to be in your scale, to look at things very closely and at the same time perceive beyond your scale in terms of wind, temperature, pressure difference, the pull of gravity, the beautiful aspect of clouds, the immense volume of water, the monolith of a mountain, and come back to your scale. Okay, sensitize your mind to understand material in relation to this what you have perceived. That is when wonder happens.
It is right in front of us, eyes that do not see.
Not necessarily something that is creative. Even an innovative practice of making a dough is technology. Actually, everything will come as a simplified simulations also. Separate how to work hand in hand with old school architecture.
So all of that only I'm saying, it's an entire new knowledge system that's not being adapted yet.
But that is because you study here.
No.
And also how
Let's say go to some side. That's what I'm saying.
Kind of fulfilling the requirement. Right? So if we take the example of Kant, if all of you were there for the lecture, if you see those sketches that he had made, take his travel sketches, take his design sketches also.
Because anyone's experience will be different, right? So how can you say a space is intimate or a space is body is in a way shaped to rate of change. Also very curious maybe because there are colleges and schools of thought which actually look at new technology and its implementation and design process.
But yeah, that can plug into agencies thoda because a lot of our agencies are manual and for good.
Something that's changing, like just like we say acclimatization, like over the course of time when we are subject
and everything, how much do we go towards that? Because at one point it stops helping us.
Because we can't predict. We are making that gap or we are reducing that gap. Gap between gap between human and technology. Human and technology. Yes. Human and tech.